Well, hello everyone, and welcome to our first installment of email question and answers with the radio shop. Now, what gave me this idea is today I come home and there's 240 emails in my inbox. Not, looking at all the other emails, but 240 new ones. And a lot of these are questions. So I started thinking, maybe it's time to start doing a video segment on question and answers, because sometimes questions, answers are more easily explained through video than it's through an email, because we can use more hands-on look at the problem, instead of just typing a few things and hitting the send button. So perhaps this is going to be something that we'll start seeing a lot more. Just depends on how the video does. So we'll look at it and we'll see anyway. But if you want to send me an email with a question or contact, if you look down below the video, you'll see the Show More tab. And just to show you where that at, every time you see a video, you look under it, you'll see the title, and just underneath of it here you'll see a little button that says Show More. Click that button, it'll bring up a drop down, and most of the time you can find several links under here, and you'll see a link that says contact information. So just follow that link and it'll take you to my website where I have all my contact information at. So that'll help you. So we'll go here and we'll look at the first question that someone has asked today. And the question is, now if you send me a question, I'm not going to put the whole email up. I might just take snippets out of the email and only going to show that part of the question. I'm not going to reveal who the question was from or anything to disclose private information in the email. So the question is, a question on the Kenwood 520. The 6-amp fuse keeps blowing about a second after I power it on. I am looking through the power supply but have been unable to find the problem. Could the power transformer gone bad? Well, yes, it's very possible that the power transformer has gone bad. But this is the part that worries me the most. And that's this. The 6-amp fuse keeps blowing. And remember the word keeps. So this means that we're testing, we're putting another fuse in, we're testing, it's blowing, we put another fuse in, we're testing, it's blowing. That is not a good sign. This is something also you do not want to do. Now remember, this is a 6-amp fuse. So we got 6 amps of current or more flowing through the circuit that's blowing this fuse. Before this fuse blows, it done said it's about a second, so we've got a second of high amperage flowing through a shorted circuit. Now this is causing other components and wiring, transformer or whatnot to start heating up, and we keep doing this, we can cause something else to fail, and we don't want our transformer to fail. That would probably be one of the hardest parts to replace in any radio, especially as there's no where to go out and buy a transformer. You've got to get one out of a used radio, which means taking a radio out of service, parting it out, it can no longer be repaired, it's missing a transformer. So to keep from doing this, we need to look at current limiting, and this way we're not blowing the fuse each time we're testing. So how do we do current limiting? Well, I'll show you my setup to do it with. This is my current limiter, and what this is a dim bulb tester. No, I said dim bulb tester. But Anyway, if you've seen my video number 21, powering up unknown conditions of old tube radios, you can go back and watch that also. So it's video number 21, and it tells a little bit more about the current limiting. So what this does is that the variac plugs into the wall. It takes the hot side of the power and runs it through these two light bulbs and then over to the hot side of the receptacle. That is if we got current limiting enabled. And you see this is current limiting in, current limiting out. When we go to the out position, the current leaves the variac and goes straight to the receptacle without any limiting. There's also a switch up here on the top, and it's labeled ×1 ×2. I'm in the ×1 position, means it's only going through one light bulb. When I go to ×2 position, the current goes through two light bulbs. This is with current limiting in. There's also a power switch that turns this receptacle off and on. Everything else stays hot. So if you plug in a radio, and all this is just a incomplete circuit. Our ground feeds straight through, goes to the ground terminal. The hot comes through the light bulbs to the hot terminal. The bulbs will not come on when nothing is plugged in. Now think of a switch being plugged in here. You plug the switch in and you turn the switch on. It completes the circuit. The light bulbs light up. I'll show you this on the whiteboard. Just a simple diagram of the circuit. So a dim bulb tester is just a very simple circuit, and what it does is limits the amount of current that's going through it to whatever's being powered by it. And all it is, let's say this is the AC plug that plugs into the wall. Over here is a receptacle. This is all neutral. This is all hot. The neutral wire goes right through and feeds the neutral of the receptacle. The hot wire will come through, goes through the filament of our bulb, and goes over to the hot side. Now if you look at it, this is our light bulb. We plug this into the wall. Your positive comes through here. It'll go around, it'll stop here. Your neutral comes to here and it stops here. We're open circuit. If we go in and we short this, now our path is complete. The bulb comes on and it will illuminate. This little shorting bar is our radio. So if you plug a radio in and it's got a short in it, that short in that radio acts like a switch and instantly turns on this bulb at full brightness. So we know that whatever we got put into it is shorted. Either bad caps, rectifier diodes, transformers, doesn't matter. Nothing in the radio is going to be hurt. The light bulb is going to take all the load. So the only difference in mine is I have two bulbs. Each one's 100 watts, so I can handle 200 watts of power. And right here I have a variac, so I can vary the voltage going to the load. Real simple circuit, nothing to it. And you can run to Lowe's and pick up this equipment under about 15 bucks and make you a current limiting device. That simple. So now what I'm going to do is just, I got the 520 sitting here on the bench and I have it plugged into our current current limiting device and I have the power on. And I'm going to just simply reach over and turn the radio on. You can see our bulbs glowed for just a minute, and now they're practically gone out. And that's using both bulbs. That radio will no ways use up 200 watts, so I'll switch to the 100 watt mode. And we'll turn it back on, and you'll see that one bulb light up bright and then go dim. No problems. So what happens if we put a radio in there that is shorted and something's wrong with it and causes it to blow a fuse? I'm going to leave it on the 120 volts. I cut the power off. And don't try this at home, not unless you really know what you're doing. I know you hear a lot of us YouTubers say so. If you're doing so, you're doing at your own risk. Well, there's a reason for that. We don't want no one to get hurt. And we can't stress enough that we are dealing with mains electricity, and it can kill you. And I don't want to hear of anyone getting killed or severely injured over doing any tests like this. So always play it safe. But what I got here is just a simple line cord with the ends cut and capped off. So if I was to plug this in and turn it on, nothing happens. And I'll demonstrate it just by plugging it in and turning it on. No problems. The bulbs are not glowing. Everything is fine. Now we'll unplug this. I'll remove the wire caps. Again, do not try this at home. I'm going to take the two hot wires and I'm going to short them together. And I'm going to put the wire cap back on. As you can see, same power cord, nothing's changed. I'm now going to plug this into our current limiter, making sure we in the in position. We don't want to do it when it's in the out position. So we're current limiting. I'm going to go ahead and switch this over to 200 watts because this is going to be a, pretty big drain. And I'm going to turn it on. And as you see, both light bulbs are glowing brightly. And I'll turn it back off. That is simulating a radio that has a major fault. And that is what you'll see on the dim bulb tester. Now to get back and answering the question, now that we've gone through the safetiest way of checking it without doing any damage, the first thing I would look at is the power cord that is supplied with the radio. As you see, the standard 520 has this Jones plug, sense plug. I forget the name of them. Jones plug is what I'm going to call it. And the problem with these, in the email he said he picked up some random radios. So if you run out to a ham fest and you see a 520 or a 101 or an old Swan sitting there and you pick it up, you buy it from the guy and you bring it home, the first thing to check is the power cord if you're blowing fuses. And the reason for that is the person that had this radio may have many radios like myself. He wanted to unload a radio. He looked around, he picked up a power cord. Well, the Swans, the Siltronics, the Kenwood, the SE had a mounted power cord that wasn't removable. Even my National has the same plug, but not all of them will work. So the first thing to do is pull up the schematic of your 520 and check this power cord and make, you have to back these little screws out, unloosen the strain relief, pull it out, and make sure that this is wired for a 520. It could be wired for a different radio. and that could be what's causing your fuse to blow. So as we can see on our 520 schematic, we see our AC line comes in and connects to pin 3 and 4. Also pin 8 is jumping to pin 9, pin 7 is jumping to pin 10. If this is different on your radio, then that could be causing the problem with your fuse to blow. So you check your power cord and you figure that was okay. The next thing I would do is go here and pull the driver tube out. Remove the cover with the power supply disconnected, and pull your 2 final tubes. Could be a chance that those tubes is shorted and they're going into oscillation, and that is causing it to blow the fuse at startup. You can, if you got a tube tester, you can go ahead and check your tubes. But if you got a current limiting, you can go ahead and remove the tubes. Make sure that your plate suppressors are hanging open. Put the cover back on. Power the radio. If you still get a bright bulb, you know that the tubes were not the problem. And don't forget to make sure you discharge before you touch the anodes of these tubes. And you can do that with a resistor through a piece of wire and some insulated pliers to just discharge the tubes. So now if we still turning the dim bulb tester full bright, it's time now to go in here and start looking. You can see our power transformer is right in the middle at the bottom, and just to the left of it, when looking at the front of the radio, you will see your rectifier unit. This is where all the wiring from the power supply comes to. You can then take your own meter, pull up your schematic, and look at these terminals where they're connected to on this rectifier unit. So looking here at our schematic, you can see there's our 6 amp fuse going over to the primary side of the transformer. Now there's also a couple of ceramic caps. These are bypass caps off the AC. I have never seen one shorted, but it is possible that one of these could short and directly blow the 6 amp fuse. So you can look at that. But what I would do is come here. You can see the secondary side of the transformer connects to this rectifier board, and you can ohm out the AC 800 to 300 to 210 to 100. And down here we're going to have our 14 volt supply, and you can ohm it out, because if any of these has a short on it, then that's going to cause that 6 amp fuse to blow. If you come here and you're not finding any shorts, then we just may have a problem in that transformer. I have seen 1 or 2 with bad transformers in it. Yes, that does happen. But if you're checking here and you're finding some heavy shorts, you know, you could have components here. There's diodes on this board that could be bad. And the reason they gone bad is your filter capacitors could be shorted. You have to remember the age of this radio. So, you know, check any filter capacitor, any diode. If you're coming here and you're checking, let's say you go to your 300 volt line and you're showing a dead short to ground. I mean 0.0 whatever ohms to ground. It wouldn't hurt to go ahead and pull this lead from the board, check it again on the board and see if your short has gone away, if it's still there. If it's still there, you know there's something in this board. It's probably shorted. If it's gone away, and then go back and ohm out that lead, and if you're getting a dead short from, say, the 300 volt to the 0 volt ground, then it's a good possibility that the secondary in that transformer is shorted. But that is how I would go about just doing some quick tests to find out where that short is that is blowing that fuse. Well, this is all the time we have tonight for emails, questions, and answers with the radio shop. But if you have any suggestions for further videos on this segment, you can let me know by leaving your comments down below. And also, if you enjoyed the video, you can let me know by your comments and by hitting the like button. So we'll just see how this series goes, and if it shows good results, we'll keep this up. And again, maybe we'll get a couple a week, or at least one every bi-weekly, and see how it does. Anyway, don't forget, hit the show more button for contacts, and links to my website will be down below. And I hope you enjoyed this segment, and if you did, we'll do some more of them. So until the next time, we'll see you in the next video.